The reminder, the domain of a function is the numbers you can replace in the domain for your input and you get an answer. So that's part of the domain. Now the implied domain for most function is a set of real numbers, except when it's not defined, and that's what we're going to have to find. So if we take a look at example 14, I want to find the domain. I could replace x in my numerator with anything, and I'll get an answer, won't I? However, since I'm dividing, remember, you can't divide by 0. Big no-no. So what happens here, if my denominator is 0, I've got a problem. So what I'm going to do is I'm going to take a look at this problem. I'm going to say, hey, when does my denominator equal 0? Well, I factor that. I get x times x minus 7. So x would be 0 or x would be 7. Either one would give me my domain, or I get a 0 in my denominator. I can't divide by 0. So what I'm going to do then is I'm going to say, oh, x can be any real number except it cannot equal to 0 or 7. Put that in set notation there. Now on example 15, you can't take the square root of a negative, can you? So what happens on 15, let me switch colors here so you can see the difference here. T minus 5 has to be greater than or equal to 0 because I can't take the square root of a negative. So in other words, t has to be greater than or equal to 5. There's your domain. So I'd say as long as t is greater than or equal to 0, then we have our domain.